I'm Benedetto Lepori. I'm professor at Università della Svizzera Italiana and at the Austrian Institute of Technology, where I'm coordinating scientific director of the European Higher Education Sector Observatory. And many of you know I'm hosting, managing the RISIS seminars, but here today I'm a double role and I will present some of my research. I want to welcome here also Lutz Bormann, who is co-author of this paper, together with my colleague Mario Gai, and I want to welcome also Mike Thelwall from University of Sheffield, who accepted to be a discussant. And I want to thank Manfred for organizing and managing the logistics of this seminar. It's the usual ordering, so I will present in about half an hour the paper, then I will give the word to Mike for his comments as discussant, then Lutz and me, we will try to answer or to comment on your insights, and then we will open for a broader discussion. As usual, please mute your micro, and if you are not eating chicken or something strange, leave your camera open. It's much better to see your faces than to see just names. So thank you. All this said, I share my slides and then we can start the presentation. Can you see my slides?
Yes.
Okay, so I have just to move around a bit the windows. Okay, so the topic is, the title of the presentation is Finding Similar Universities Using ChatGPT. And it's a large-scale comparison using ETER data. And I said it's worked on by me with cooperation with Lutz Bormann from Max Planck Society and with my colleague Mario Gai. So just to start with the topics, we all know how it's important, but also trendy to compare universities across the world. And there has been a long discussion. You know, the main tool for comparison which is used by people is rankings. And there is a sweeping critique about the fact that they compare very different institutions. So in rankings, you find institutions very different by size, by research orientation, by subjects. And we agree that we should avoid comparing peers with oranges and try to compare institutions which are similar. By some core characteristics, like, for example, the size. We all think it's pointless to compare a university with 1,000 professors with a school with 100. By subjects, because most things change, including bibliometric measure when you have different subjects. By institutional mandate, for example, avoiding to compare research universities with mostly educational-oriented school, etc. And this comes with the idea of benchmarking. So benchmarking is we try to find similar universities out there in the world, in Europe, and then we try to compare across using a set of indicators. And as I said, most scholars would agree on the main dimensions you need to consider to identify peers. So mostly size, subjects in research and education, and the importance of research in the institutional mandate. But if you look around, there are very few systematic implementations, so very few tools which allows you to go there and say, I want to find a university similar to my own universities and to compare with. And there are maybe two reasons. One is data requirements. So to create a database-related tools around this dimension, you need good data. Now, we might have better data now in Europe thanks to the European Tertiary Education Register. There are good data in the United States, but it's rather recent. But the other one is the complexity of the approaches for the users. And what I'm showing you is the benchmarking tool developed by EU Multi-Rank, which will be taken over by the European Higher Education Sector Observatory. All nice, all very robust, scholarly based on dimensions, on indicators, etc. But if you are a user, an institutional manager, a rector, and you start saying, okay, I need to choose to compare by all these variables, this becomes simply too complex. So it's constraining, it's complex, it is not necessarily easy for normal users. Maybe for us as a scholar, yes. So one idea is there might be an alternative, and that's an example of alternative. So I went to ChatGPT. This is the latest version 4.0. Say, please, ChatGPT list 5 universities in Europe that are most similar to Humboldt University in Berlin. And ChatGPT thinks a while and comes up with a list, and you would say at first glance, is not a very bad list. These are all large, research-intensive, etc. But then what is even more interesting, if I follow up and say, could you add information on number of faculty, subjects covered, research performance, ChatGPT is able to retrieve reasonably good information. It tells you by university, the academic staff, the programs, the research performance, etc. So as an average simple user, a student, a manager of an institution, a rector, I might think, okay, that's the good, a reasonable solution. It's very widely usable for users. But actually, we don't know. And when you start testing this, in some cases, you get very reasonable results. In some cases, you get very strange results. And of course, that's part of our scholarly work to assess what works and what does not work. So the topic of the paper is to start from the remark Lutz, Bormann, and myself we made that ChatGPT seems, at least in some cases, to find reasonable peers. So it works in some cases. It's far easier for end users and is not so heavy in terms of data requirement. You don't need to have a large-scale data collection, etc. And maybe it could take into account all the similarity dimensions, because tools are pre-programmed by the designer of the tool with the dimensions, and as a user might be interested in all the dimensions. But we don't know how good are the peers in terms of general similarity criteria. So whether, for example, we get institutions of similar or dissimilar size. We all agree size should be reasonably similar. The extent to which results are affected by the query design, that's I'll come back later on this. The query design, how it's written, is hugely important, influential on responses of ChatGPT. So we don't know, in our case, how much it's affected, which wording works and which wordings gives out results, and whether there is any systematic bias in responses. So you get more systematically large universities, you get systematically internationally visible or sectorally visible, you get systematically more generalist or more specialist universities. And since we have from the European Tertiary Education Register a large sample, it's 1,300 universities, it's almost all PhD awarding institutions in Europe. So we can test ChatGPT systematically and see what comes out and go beyond the idea of being just episodic, of trying one or two universities, but comparing systematically. Now, something which came as very clear when starting pre-testing is that you need to understand what ChatGPT and language model do before starting to evaluate, in order to ask the good questions, but in order also to interpret the results. And that's the most important thing is that behind ChatGPT, so you interact with ChatGPT, it looks like a human being. It's talking, it's like me talking, answering, etc. But there is no human being behind. There is a so-called large language model. And large language model shared with most natural language processing, used also in scientometrics, what is called the distributional assumptions. So the idea that you can infer meanings from joint distribution of words in text. So the idea, you don't need to understand what is a large university, what is an online university, etc. So you don't need an ontology, but it's enough to look to recurrence patterns of words. That's the distributional hypothesis. Large language models bring this capability beyond what we know from word embeddings, from latent Dirichlet allocation, topic models, etc. So in terms of the amount of data they can pre-train and use, and the ability of working also on very distant associations, so not immediate co-occurrences of words, but co-occurrences which are chained by different long-range association. And a capability large language models have is to generate text of high linguistic quality. That's what makes them specific for the end users. If you run a word embedding, you get a complicated statistics. ChatGPT gives you an answer in good shaped text. But this does not change the fundamental characteristics of a large language model, that they don't reason based on knowledge schemes or ontologies, but reflect just association between words in texts. For example, we will see ChatGPT, when you deal with university, has no idea that a university and the department are ontologically different. One is a component of a larger organization. So they might confound universities and departments because they come together in a text, which is unlike human being work. So if you read texts in cognitive sciences, we are an ability of treating word associations, so linguistic capabilities, but far below now what language models can do. But we have also a cognitive way of thinking. So we have high-level knowledge schemes, ontologies, etc., that superimpose to the linguistic reasoning and to the linguistic interaction in human. ChatGPT, like language model, does not have this capability, even if it looks like it's reasoning, but it's just saying, I found this word associated with another word. And this is a fundamental aspect that you can see in apparently strange responses. One very popular is, I ask Mark, I tell ChatGPT, Mark like koalas, then his preferred food is, and then ChatGPT goes directly into the game and say, my favorite food is like eucalyptus leaves, because ChatGPT is associated Mark with koalas and koalas with eucalyptus leaves, and that's the only association ChatGPT has. This is showing exactly the reasoning. Now, I have to say, in some other cases, large language models seem to be learned to detect these kind of problems. For example, something linguists tried is Mike likes favorite color is yellow, my profession is, and ChatGPT used to answer bus driver, because most buses in the world are yellow. Now, I tested 2 weeks ago and I got an answer like, hey, you did not give me any relevant information about profession of Mike, so I cannot answer you. So in a way, that's the extent to which this kind of spurious association can be detected is rapidly evolving. But this does not change that the fundamental basis is still association between words. And the outcome of this is that when you conduct evaluation of large language model, there is a huge literature on that. You see large differences in performance by task. So evaluation agree text generating capabilities are excellent. ChatGPT performs in creating new sentences, new texts. So not just copying texts from Wikipedia, but creating new texts, performs better in terms of linguistic quality of many native speakers. So this task, which is a linguistic task, is mastered very well. Then the evaluation says what you would expect, and that since they have been trained on corpus out there, ChatGPT cannot, language models can only reproduce biases of the underlying data sources. For example, in terms of culture, language, gender, if you say Jane is a pretty woman, Jane profession is hostess, you get exactly all kinds of stereotypes about gender, about culture, about race. You get out there in the data sources, including Wikipedia, which is one of the major sources. So you would expect to find similar problems in university. Then, of course, the issue is whether language models are good in semantics. So comparing events, and then the results show that these models are pretty good in evaluating semantic consistency within events, such as plausibility of a sentence. If I say Lutz is a man and Lutz has 4 legs, ChatGPT will say, hey, there is something wrong here. It's not consistent internally. But it has much more problems in relating events. So saying this event is connected to another one. So the case of koalas, it's typical. One event is I like koalas, and one event is koalas like eucalyptus leaves, and then I like eucalyptus leaves. So you have this kind of shifts. And what linguists say, or cognitive scientists, of course, large language models are based on word probabilities. It's word distribution behind that. As complex as it can be, as with many parameters, but still is probabilities of word distributions. And they lack what we have in our mind, that it's some global ontology which checks about plausibility. So we can discuss step by step as humans, but we have behind some cognitive schemes which says, for example, taxonomies, etc. And at some point, we say the chain of reasoning comes to an absurd. We say, hey, there is a problem, I restart. Language models don't have this kind of controls, because they don't have a cognitive layer. So there is always a non-null risk language models are taking a completely wrong path, just because of probabilistic distribution. You can reduce these mistakes by careful design of prompts. So clearly some of the examples I showed you, like koalas, are made to disguise ChatGPT. But if you want to use it, you should not try to get the wrong result, but to help to get good results. But the possibility that ChatGPT goes completely wrong cannot never be excluded because of this linguistic structure. However, as I said, performance of these models is rapidly improved also for semantic tasks. I think 5 years ago, no linguist would have thought that language model could be so good for semantics. It's far beyond every expectation, so we don't know what will come. So this is clearly a moving target. Okay, but then this is important for our purposes, because it means we want first to assess the existence of biases. Second, to see whether the design of prompts gives good or bad results compared to what we could get with conventional benchmarking, and find the areas where ChatGPT is more precise and less precise. To do this, we said we have the overall population of European universities from the European Tertiary Education Register. So, which is nice, because we will be asking ChatGPT find 5 similar universities in Europe, and we have basically the whole population, delta some corrections. So we can really compare the peers found by ChatGPT with the overall population in Europe and look whether there are more or less similar cases. And from ETER, we have data on these main similarity dimensions. We could have authors, but we focus on sites measured by personnel, on subject composition measured by the distribution of students by fields, and on research intensity, basically population, publication divided academic personnel. We build classes, large, small, very large, etc., to compare. And then for all universities in the sample, so it's a mass query, 1,300 queries saying, ChatGPT, we give you this university, please find the peers. about the 5 most similar universities in Europe. Then we rematch results with ETER. So we reattribute the ETER IDs, and then we can compare really the distribution of peers, the characteristics, and we can also start comparing differences depending on the query strategy. And that's still preliminary. As I will say later, we will make a further round of tests. But the idea is to focus on simple prompts, because users will not want to make very complicated queries, maybe using APIs, etc. So it's meant to be a test of usability for normal users. We test few variants then to privilege also large-scale comparison. So the goal is not to test for few cases systematically all possible variants. And we follow insights of evaluation studies of language models that ChatGPT works better if it's not too constrained. So in a way, you should try to leave the model search rather freely and constraints as less possible. So the basic query is simply list me the 5 universities in Europe that are most similar to the University of Leuven, for example. And we can give the national name and the English name. And then we could extend the query, saying, giving ChatGPT some more information on what we want as similar. So list the 5 universities in Europe that are most similar in terms of the number of faculty, subject coverage, and research orientation. So we are more explicit on the dimension. And then what we can do is to ask to add quantitative information. So could you add the information? Because ChatGPT does not always give you the numbers. But if you ask, could you give me the faculty numbers of these universities, ChatGPT gives you results. But all this, it's preliminary. You will see that some of the first results we got suggest also maybe some changes in the query strategy. But the overall query will be that strategy will be that a simple basic query plus some simple variations. Now, preliminary results. When we compare, we rematch the peers, 2/3 of the peers and 85% of the peer mentions are ETER universities. So ChatGPT stays more or less in the same perimeter, and probably some are due to the fact that the matching has not been completed. We get some non-PhD awarding institutions, and this is expected because among PhD awarding institutions, you have universities which used to be colleges with little research. So ChatGPT sometimes gives you a college as a peer. So that's perfectly normal. We have several cases of faculties or departments proposed as peers, like you have Theological University in Trier, and ChatGPT says you a similar institution is University of Copenhagen because University of Copenhagen has a stronger theological faculty. So you get these kind of things. And you get few cases from outside Europe, and I'll come later because there are very specific reasons which enlighten us a bit the mechanism. But among, you remember we have 1,300 universities or basic sample. Less than 200 have more than 9 peer mentions, so are mentioned more than 9 times as a peers of another university, and account for more than half of the mentions. So up to 40 or 50 times. So, and the largest one, the top ones are large universities. Most of them research oriented, but some like Istanbul simply very large, but not necessarily very highly reputed, with over 30 mentions. Very large universities are 7 times more expected peer mention than small ones. So there is a much higher likelihood for ChatGPT to pick a large or a very large university than a small one, despite the fact that the original sample of focal universities is populated mostly by small ones. So the focal university you give to ChatGPT are mostly small, and the peers you get are mostly large. So there is a very strong bias. And there are no significant differences in that respect between the simple and extended query. So there is a clear evidence of bias towards large and research-intensive universities. That's, for example, that's a negative binomial regression, is the prediction of the number of times a university is mentioned as a possible peer, depending on some characteristics. And you see these are exponentiated coefficients, so are multipliers of expected number of peers. So you see a very large university as a expected number of mentions 7 times a small one. A university with very high research intensity, more than 2 times as one with low research intensity. So that's just to substantiate these statements statistically. That's the advantage of having so many data. And it's interesting to look to some examples. These are the peers, the universities for which TU Munich is proposed as a peer. And you see some are very large. You see Federal Institute of Technology of Lausanne. All of them are technological, but some are not so large or not so visible. So Tallinn University of Technology is a normal university of technology with quite a lot of research, but it's for sure not TU München or EPFL. And you see ChatGPT says always both universities emphasize engineering. It's recurring, are leading technical universities, are strong research universities. So the way it's given tells you what is the peer. So it says Tallinn University of Technology is a strong technology university in Latvia, I think. And then it compares with TU Munich, which is a leading research university as well. And then if you are more overt asking about the characteristics, the peers don't change so much. What changes is the wording. So ChatGPT starts saying, although TU Munich is larger in size than they share strong engineering, etc. So the association don't change, but you get an explanation which says, hey, these are associated, but there are differences in terms of size, etc. So one important conclusion, it's not so easy to influence the behavior of ChatGPT by constraints, like giving similar size, because in many cases, it tends to override this, and then it seems to conform largely to self-descriptions. So I think most of these institutions will have in their website leading technological universities, for example. And then ChatGPT reacts to the jargon or the self-presentation. And this is a measure of size difference. So between the proposed peer and the focal universe. So if you have 0, the size is the same. If you go above 0, the proposed peer is larger. So you see that for very large universities, the size of the peers is more or less the same as the focal university. So you get very large universities matched with very large universities. But when you give to ChatGPT small universities, you get, again, very large and much larger, up to 5, 6 times larger. And the simple and the extended query are not very different in that respect. So we expected that saying, okay, we want similar size would improve strongly the situation. It did not. And I'll come later on this. So then what we did is to start looking to some cases, to try to understand the behavior. And this will likely suggest also refinement of the query strategy. So I give you some examples. So on the left, please list the 5 universities in Europe that are similar in terms of number of faculty, subject coverage, and research performance to the Technical University of Brno. And on the right, please list the 5 universities in Europe that have the same number of faculty. So it's not similar, it's the same as the Technical University of Brno. And you say on the left, you get a lot of size bias. you get the Munich, you get the Delft, you get Vienna, Karlsruhe, etc. So all very large. On the right, when you say the same, you get Czech Technical University in Prague, Wroclaw, Budapest, etc., which seems to be quite better peers, at least dimensionally. So you notice that just changing similar to the same changes quite a lot the outcome in this specific case.
What never did.
Yes? Okay, but if you ask, list the 5 universities in Europe that have the same number of faculty to University of Lucerne, you get very reasonable peers in terms of size. But as soon as you add faculty, subject coverage, and research performance, ChatGPT starts mixing things again, and the bias reappears. You get University of Basel, which is 10 times larger than Lucerne, for example, because you ask same number of faculty, but same subject and same research performance. And then ChatGPT can tell you a Basel has the same subjects, but is different in size. So the problem of adding multiple constraints is that all this goes in a basket in this linguistic association and blurs comparison. So one lesson, queries should be as simple as possible, because otherwise it's unpredictable how the different attributes combine. Then something more positive, if you ask list 5 universities in Europe similar to University of Alberta in terms of number of faculty, you get the Open University, you get Fern University in Hagen, you get Paris Descartes with the motivation it has a lot of online, you get London Worldwide, which is the distance education department of University of London, and you get Athabasca. And you see that ChatGPT had a correct understanding of the main characteristics. So that's an open university, to the point that since there are not many large open universities in Europe, it gets University of Athabasca in Canada, even if you say Europe, because it primes the similarity in terms of educational offer on the fact of being in Europe. And then you see how ChatGPT might interpret, under guillemets, because it's not a reasoning tool, similarity in different ways. One is having a full distance university like the Open, one is having a university with a large open education department. So the interpretation of these similarities might vary, but nevertheless, you might notice it's very difficult in a data-driven tool like the multi-rank benchmarking tool to take into account these characteristics. It's very quick if you don't have a descriptor for open universities that you get a similar university as the Alberta, which is a perfectly normal campus university. So let's come to a summary and some reflections heading towards the discussion. So first, you get a very strong bias towards large and research universities. You can try to force out this bias by very tight wording. Please, I want the same number of faculty. But as soon as you need to combine to have the same number of faculty, the same subject, and the same research orientation, blurring reappears and things are difficult to control. So it's hugely difficult to avoid bias in this game, simply because the model has been trained with the bias in it. On more positive sides, you get from ChatGPT good interpretation and description of the local university, better probably than most databases. It gives you a fair account of what a university is, specificities, what is done, education, research, etc. And also a fair account of differences. Even if ChatGPT might give you a very large university as comparison for a small one, the tool will tell you, even it's very much larger, it shares something else. So it's very transparent in that respect. The quality of information seems to be reasonable. In the next round, we will ask systematically about faculty numbers. And since we have the European Tertiary Education Register data, we would compare. I would suspect that for users that are not interested in the third digit measure, but are interested to know whether it's 1,000 or 100, the quality of information, it seems to be very, very reasonable and much easier to get, by the way, than getting statistical data. And so that's something positive. The meaning of similar or the same can be highly variable, exactly because there is no ontology. So ChatGPT does not know that universities and departments are very different entities organizationally, that distance universities, so full distance universities, are not the same as distance programs, online programs, etc., because it lacks a proper ontology. And then my conclusion or my current thoughts, I said it's a preliminary work, and we are here to learn and to get your insights to advance. There is no way to straitjacket ChatGPT to reasoning like database design benchmarking tools, because tools like the multi-rank one are really ontologies, knowledge graphs with a clear predefined definition of dimensions, characteristics, measures, etc. So there is no way of having ChatGPT behave the same way, because the base is completely different. Results will always be less precise. So it's a wrong benchmark to compare the ability of ChatGPT to measure similarity by size. You use statistical data. But then we should ask ourselves whether the comparison we propose by predefined definition are really what users want. So if I'm wishing to find a distance university in Europe as my comparison, I might not find them just comparing size and research intensity of institutions. I might need to add this kind of characteristics. So for sure, database-driven comparison are very useful and important for statistical comparison. If you work on large sample, you run statistical models, etc. It's not so clear whether they are exactly what end users will want. And definitely there are some useful characteristics of language models which come up. The openness to author similarity dimensions you might not have thought when programming a tool. Distance universities are a category we know, but there might be author subgroups of institutions we don't know, we are not aware of, etc. A lot of flexibility. So you might get unexpected cases, and some might be totally wrong or not interesting, but some might be relevant. Say, I did not think about this institution, but indeed, the university shares with my university some characteristics. And for sure, good description of cases of similarities and differences. So if you want to know what a university is doing, you might read Wikipedia page, but you know that Wikipedia page is an official page, so it will be anyway biased by those who write it. But ChatGPT gives you reasonable quality of information and even of statistical data. As far as we can judge now, it's very difficult to define ways of interacting, because the way language model respond is very localized. So the interaction needs to be customized case by case and stepwise. We don't think there will be the magic query which fits all needs of users and solves all cases. What you get out of a prompt needs to be refined and by further interaction. But users definitely need guidance on which questions might ask to avoid falling in the koala's trap just by writing the wrong word, for example. And how to interact to drop non-relevant cases. So how to instruct ChatGPT that if you start getting for your small local college ETH Zurich, you can tell ChatGPT, I don't want this case because I want really cases which are more similar. And one question is whether tools can be developed to help users do that. As I said, it's preliminary work. So based on the interaction and the discussion we are having, we will systematize the queries. So of course, you see there are additional ideas, and push the comparison to a more systematic level, because the big advantage we have is the large sample, having systematic data, and so we can test beyond just episodical trying and typing and curiosity. So thank you. I stop here, I stop sharing, and I would like giving the word to Mike for, except maybe Lutz, you want to add something?
Great presentation. I only want to add, I'm not only active in the research on research evaluation, but also in the research evaluation practice for the Max Planck Society. And there's very frequently the question for peers. So the people are not so interested in advanced bibliometric indicators, but they want to compare institutions or researchers with peers. So for the research evaluation practice, I would say it is a very relevant question to have a method for the identification of peers. And yes, maybe ChatGPT can be used for this purpose, especially because the people who are interested in comparing the focal institution with the peers, they frequently do not know which peers should be used here. Okay, thanks.
Thank you. Then I'll give the word to Mike for your comments and critique.
Okay, thanks very much, Benedetto. Yeah, really interesting presentation. And it's wonderful to see this application of ChatGPT, and particularly like the way that you've evaluated it and checked it for bias, and being critical about how useful it is for this task. So that's really wonderful to see. Good practice. So I'll just say a few things. They're comments more than questions, but you can come back on them if you like. So the first thing, I think bias is really an important issue. So you've raised that, and I think it's very frustrating for large language models, including ChatGPT, the fact that they're completely opaque. We don't know the process that they've used. We don't know the details of how they've come up with each response that they give, even though, as you've explained, we know the technology behind them. We still can't see the track of evidence that leads to each individual response. So I think it is very important to check for bias. Just because it's not obvious there's a bias doesn't mean that there is a bias. And you've shown here in this, with your case study, that there's a major bias for this result. So I think looking for biases and finding biases is really important for any kind of research with ChatGPT. So this is great to see. So a second point, so with my own use of ChatGPT, one of the things I've found frustrating is that if you ask it a query that isn't simple, then its answer is always different. You ask it the same query and its answer is always different. So of all the complex queries I've given ChatGPT, I've never seen it give the same answer twice. So it's always given a different answer. And I've tested it with giving the same query 30 times in a row. I've given it hundreds and hundreds of queries 30 times in a row. And every time I've run these queries, it gives a different response. So they can be slightly different, but usually they're quite substantially different. So a different structure, different words, different recommendations. And even if it's a simple query, like is this statement true or false? If I ask some statements, if I ask ChatGPT, sometimes it says they're true, sometimes it says they're false, and it gives different reasons each time. And even if the question is identical, the answer can be different. So that's something I find frustrating with ChatGPT, that it's difficult to work out cause and effect. So if you change the query you give it, you get a different answer. But on the other hand, if you don't change the query and you submit it again, you also get a different answer. So it's hard to work out exactly what you've done that has made the difference. And so I think you need to repeatedly ask the same query. If you're going to check to see if a change makes a difference, you have to submit the query lots of times in the first wording and then lots of times in the second wording, and then try to work out what the pattern is between the two answers. So I think it means a lot of work to decide whether a change in a query actually has any effect on ChatGPT, or what effect it has on ChatGPT. And so the third point is, so I like your idea to develop a system that would help the user to generate effective queries. So I thought that's really a really good idea. So users on their own, especially now, might find it difficult to come up with the right query, so they can get information that isn't particularly useful for them. And I think I've seen some good systems that help users to design queries for specific purposes, or even ask the user for information and then build the queries themselves to submit to ChatGPT. So they, a little bit like your template, they fill in the blanks from the user to build the query and then submit it. So my experience with ChatGPT is that it gives better answers if you give it more context about the queries. So if you ask it to find similar universities to a given one, then it might do a better job if you explain to it why you want to know similar universities. So if you said, I'm a research evaluator, looking to find a university that I can bibliometrically compare to this one, then maybe it will give a better answer than if you just ask it find similar universities. Or if you told it something different, I'm a student and I'm going to this university and I want to go to another university that's very similar in another country, then maybe it will give different types of answers, but it will give more appropriate for that query. So my experience with ChatGPT is that it is good at getting the context and getting answers, giving better answers for that context. So your example of the koala leaves, that's a bad example, which goes against my point, where it gets the wrong information from the context. But I think in general, it is quite good at getting information from context. And final point, one thing I found frustrating with ChatGPT is the changes. Probably more of a worry than frustration, but the change in the system upgrade. So every 6 months or so, we're getting major upgrades to ChatGPT. So there's another one which I think is in beta at the moment and due out at the start of next month, the 01 version. And it's a worry for me that we do lots of research with ChatGPT, and then there's a new, more powerful version, and then what are we going to do now? I'm sort of hoping that it peaks in its ability, and now we can start to do kind of more stable research with it. But yeah, that's an ongoing worry, and I guess the best solution might vary when a new, more powerful version comes along. So that's all I wanted to say. So thanks again for the talk. Yeah, really interesting talk, Benedetto, and congratulations on the paper.
Thank you, Mike. Lutz, do you want to add something?
Yeah, I could comment on some comments from Mike, if you want, or do you want to start, Benedetto?
So you can start.
Okay. Yes, concerning the first point, that large language models are black boxes, and that we should check for biases. Yes, I think this is a very important point. What we already have seen in our results is a bias for large institutions. I think this is clearly observable. but I'm not sure how this can be avoided. Maybe these are the institutions which are well known, which can be very frequently find on the internet, and so they will be frequently mentioned in the results of ChatGPT. Yeah, your second point, the missing reliability of the results from ChatGPT. Yes, it is a big problem, and I observed this also in other contexts. Yeah, but I'm not sure how this problem with ChatGPT can be solved. Yes, this is an open question, and it's a big problem, especially for research, because yeah, one should produce results that can be replicated or which are reproducible. Your third point, the support for designing queries. Yes, I think this is a very important thing, not only in the context of finding peers. I think it is always the most important point if you use ChatGPT, yes, to formulate the right query. Your fourth point was the context information that is your fourth point also focused on the design of queries, that it is very important to have to include context information in the queries. Yes, I made similar experiences with ChatGPT, that context information are very necessary, and that it is very necessary to say, yes, that we are interested in peers for benchmarking studies, and then one can expect the best results. The last point, yeah, the publication of new versions of ChatGPT, and yes, we can hope that we will receive better answers using the new versions. What we can expect are different answers, I think, but this is also the case with the same version. So yes, let's see what will come with the new versions. Thank you very much, Mike, for your comments.
Yes, thank you. I rejoin, and maybe to add something. First, what is the specific to the study we are conducting is exactly that we have the full population of European universities. So, because most results on these issues are more or less anecdotal, in the sense you try one or two and you get to conclusions, it's important to understand how this effects works at large. Because for some type of university, you get pretty good peers, but I don't think we need ChatGPT to find us a peer to Oxford. The results may be obvious and already from the knowledge we have. The real problem for finding peers is you get the music school in Tartu and you want to compare, and you don't know even too much about the space. Which means also in terms of strategy in the paper, we have also limitations. So we cannot replicate queries 50 times or 50 types of queries, because we would have too many data. So it should be simpler, but some of the points can be really integrated. So I think bias, I agree, it's an important focus. And the real question for me at this stage is not whether there is bias, but whether bias can be controlled or not. It seems to be more difficult than you would expect at first glance. I'm not so surprised in reality. I think instability, we might at least compare two iterations of the same queries. And then the question of instability probably should be seen as a relative question, because one thing is to get slightly different description of the same universities. One thing is to get new peers, but nevertheless, there are still good peers, because there might be 50 potential candidates to be similar to my own university. And if I get 5 on one turn and 5 another turn, but they are within these 50, that's still okay in a way, in substance for the task at hand. So stability should be seen as stability related to the task. I think we should test at least one variant with context. So I'm a institutional manager wanting to compare my university with similar ones in Europe and see whether it changes something. And I really came to the conviction, to sharing the same idea as you, that the outcome is might be a set of good rules for users, how to cope with this system, so that they minimize in a way the bias. And there is one rule we did not mention, is not to be too much attracted by the good rhetoric of ChatGPT. So ChatGPT would like, it's a good seller. It's always very polite, very convincing, and say, yeah, this university is larger than another one, but they share this and that characteristics. And then you look and say one university is 1,000 professors and one is 20. So it's large. So one main recommendation I would get is never trust the reasoning, exactly because it's probabilistic. So you need, when ChatGPT signals you a difference, you need to dig, for example, in the size of that difference, or to ask ChatGPT how different are in size, etc. But I do think this is a major direction the paper could develop at the end, on the background that the tool is out there. We cannot forbid our colleagues to use it. We cannot change the tool because it's a black box. Everything we can dream of customized tools with more complex settings, etc. But the reality, most people will still use these generic tools. So it's an important task for our profession to explain ingenious users how to use these tools. It's like when you use Google search or these kind of things, you need to know. So thank you so much for these comments, which are really helpful. And I would like to open for questions or comments to the whole audience. Who wants to break the ice? No additional questions. We exhausted all questions. Yes, sir.
Hi, can you hear me, Tom?
Yes, we don't see you, but we hear you.
So I'm in a study hall, so I'm speaking a little like that. Thank you for the talk, and I wanted to ask. So I'm in this master's program in higher education and research, and it was really exciting to see this because I feel like I without the ETER data, me and my batchmates sometimes ask ChatGPT for, like, when we're doing case studies, or when we're working on assignments for similar universities, and we get some examples, but then we have to obviously cross-check, and sometimes it works out and sometimes it doesn't. Now, moving to the question, do you think it would be, in the coming years, it would be acceptable to say that in your research methods to say, okay, I use this data set and I used the LLM model to find similar universities, and that's why I chose this university to compare with that university?
So I did not understand. You think it would be acceptable to use language models for this task?
Yes, for finding examples of similar universities for research in general.
my current opinion, but it's an opinion that it depends on what you want to do. So if you want to do a large-scale statistical analysis of similarities between universities of performance, etc., you need to use databases. So it's perfectly right to have databases like ETER for doing this kind of task, also for restricting comparisons. But after having tested language models, I think probably for finding similar universities for users, so a university professor wants to find a university with whom to cooperate, I might really imagine that language model and conversational interfaces, so like ChatGPT, will become widely used. At the end, it's a tool. Like now we are constructing literature review by searching Google Scholars. We are using Googling things, etc. So I think it will become widely used. For this, I mean for users. As a scholar, I would need strong argument to use ChatGPT for scholarly analysis, saying I'm finding 5 universities similar thanks to ChatGPT. I'm comparing them for a research paper. So I think it might be a way. It's like when you do a literature review, you search for a word in Google Scholar, but then you don't simply list the results. You look to the results carefully and you take the cases which are more relevant. So I think it can be a tool, but the rules of proper systematic comparison should still apply. Thank you.
Thank you.
So let me add perhaps that the tool ChatGPT should only be used for finding peers. You should only use it as an experienced user. So it is very important that you can interpret the results, and I think the results can be used for ideas, for hints to interesting peers, but the selection of the peers for an evaluation study should always be done by a human, based on longer experiences.
Yes, but Lutz, the problem will be that most actual users will not match your standards. So I think it's very relevant what Mike says, that helping, so developing good practices, it might be very important.
Yeah.
Any other questions? So if not, I would like to thank especially Mike and Lutz for joining and for very helpful comments, which will help us to advance, hopefully, our research and to bring it in a publishing form. And of course, the topic is so highly relevant and actual that we feel we are in something where we need to invest. I have still to remind you of the next research seminar. I think Manfred will be posting the link on the chat, if not already done. Yes, I'm sorry, I'm looking to the chat. Okay, it's posted. It's the 16th of October, and we will go along our data-oriented approach to higher education. There will be a presentation by Joanna Volcher-Derlach. It's an economist who works on efficiency of higher education, and they match the PATSTAT with the European Tertiary Education Register, so opening an important direction in covering technological output of universities. And there is lots of concurrent work on combining patent data with the European Tertiary Education Register. And we will see the methods, but also the result of this exercise. So if with this, I thank you and I wish you a good afternoon.
Bye.
Thank you.
Thank you.
Thanks.
Thank you. Bye.
Bye.
Thank you.
Bye.